Hi everyone, welcome to lecture 17 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today, we will cover how to calculate mass percent of different elements in a compound. Okay, mass percent gives us information about the percentage of each element that is present in a compound. For example, the mass percent of different elements in ethanol are, this is ethanol, so the mass percent of the different elements in ethanol are carbon 52.14%, hydrogen 13.13%, oxygen 34.73%. So mass percent tells us that the mass percent of carbon in ethanol is 52.14. It tells us that the mass percent of hydrogen in ethanol is 13.13, and it tells us that the mass percent of oxygen in ethanol is 34.73. So this is what mass percent helps us to achieve. It helps us to know the mass percent of the individual elements that are present in a compound. For you to calculate the mass percent of different elements in a compound, you will need to know the molecular weights in gram per mole of the individual elements in that compound. So whenever you are asked to calculate the mass percent of different elements in a compound, you must be given the molecular weights of the individual elements in that compound. And then to calculate the mass percent, you divide the mass of. So there are two steps that are involved when you are calculating mass percent composition of different elements in a compound. So the first step is to calculate the number of individual atoms in the compound. For example, if you are given ethanol, you need to calculate the number of individual atoms in this ethanol. So you need to take note of the fact that there are 2 carbon atoms, there are 5 plus 1, 6 hydrogen atoms, and oxygen 1 atom. So you need to take into account the number of the individual atoms. So the first step is to calculate the number of the individual atoms in the compound, and you have to note the subscripts that are attached to each element. So for carbon, you have to note that there are 2 carbons. For hydrogen, you have to note that there are 5 plus 1, 6 hydrogens. The second step is to calculate the percentage by mass of the individual elements in the compound using the formula mass percent is equal to mass of the element divided by mass of the whole compound multiplied by 100. So these are the two steps. Whenever you are asked to calculate the mass percent of different elements that are present in a compound, you have to follow these two steps. Okay, let's look at this practice example. Calculate the mass percent of each component in ethanol, and you are given the molecular weights of the different elements for carbon, for oxygen, and for hydrogen. So first we calculate the number of individual atoms in ethanol. So mass of carbon is equal to 2 mole multiplied by 12.01 gram. So this 2 mole, we got it from here because there are 2 atoms of carbon. So 2 mole multiplied by 12.01 gram. This is the molecular weight for carbon, which is given. And then we have written the gram per mole, which is the unit for molecular weight. We have written it as gram divided by mole so that units can cancel out. So when we write it this way, this mole will cancel this mole, and we will get that mass of carbon is equal to 24.02 gram. So for mass of hydrogen, if we look at the formula, there are 6 hydrogen atoms. So 5 plus 1, 6. So it will be 6 mole multiplied by the molecular weight of hydrogen, which is giving us 1.008 gram per mole. Again, we have written it gram divided by mole so that units can cancel out. So this mole will cancel out this mole, and our final answer will then be in gram, because gram is the only unit that did not cancel out. So mass of hydrogen is then 6.048 gram. For oxygen, we do the same thing. So in this formula, we only have one oxygen. So it will be 1 mole multiplied by 16 gram, which is the molecular weight for oxygen. So divided by mole, again, we write the unit in this form so that units can cancel out. So then this mole cancels this mole, and our final answer is 16 gram. So if we add the 3 masses together, if we add the mass of carbon plus mass of hydrogen plus mass of oxygen, we will get the mass of 1 mole of ethanol, which is then equal to 46.07 gram. So this is the first step that we have to follow before going to the second step. Right, the next thing is to calculate percentage by mass of each element in ethanol. So, mass percent carbon is equal to mass of carbon in 1 mole of ethanol divided by mass of 1 mole of ethanol times 100. So this is the formula that we will use to calculate the mass percent for carbon. So we calculated from the previous slide that mass of carbon in 1 mole of ethanol is 24.02 gram. We divide that by mass of 1 mole of ethanol, which we also calculated from the previous slide to be 46.07 gram, and we multiply by 100, we will get 52.14% carbon. Notice here that this gram cancels this gram. So that's then the reason why our answer is in percent. You do the same thing for mass percent hydrogen. So using the same formula that we use for carbon, we put the value that we calculated for mass of hydrogen in 1 mole of ethanol, which is 6.048 gram. We divide that by mass of 1 mole of ethanol, which is 46.07 gram, that we calculated from the previous slide. So this gram will cancel this gram, and our answer will be 13.13% hydrogen. We do the same thing for mass percent oxygen. The value that we calculated for mass of oxygen in 1 mole of ethanol from the previous slide is 16 gram. We divide that by mass of 1 mole of ethanol, which we calculated to be 46.07 gram, and we multiply by 100. So this gram cancels this gram, and our answer will then be 34.73% oxygen. Okay, so the percent composition of the elements in ethanol are carbon 52.14%, hydrogen 13.13%, and oxygen 34.73%. We calculated all these percentages from the previous slide. And if you want to check whether the percent composition of the elements you have calculated are correct, you need to add all calculated percent compositions. If you add all of them, they must add up to 100 if your calculation is correct. So if we add up all these three percentages, they are equal to 100. So this then shows that our calculations are right. So this is a way for you to check whether your calculations are correct. All percentages must add up to 100. So let's look at another example. Sucrose has molecular formula C12H22O11, and you are asked to determine the mass percent of each element in sucrose. You are given the molecular weight of the different elements. So the first thing we do is to calculate the number of individual atoms in the compound, taking into account the subscripts that we have here, because that shows us the number of each element that is present in this compound. So mass of carbon will then be 12 because there are 12 carbon atoms multiplied by 12.01 gram, which is the molecular weight for carbon. Again, we write the gram per mole as gram divided by mole so that our units can cancel out. So if we do this, mole will cancel mole, and we will get 144.12 gram for carbon. We do the same thing for hydrogen. Here we have 22 hydrogen atoms, so it will be 22 mole multiplied by 1.008 gram divided by mole because it's gram per mole, and mole we cancel mole. So mass of hydrogen will then be equal to 12.18 grams. So it will be in gram because gram is the only unit that did not cancel out. Mole has already cancelled out. So it is advisable for you to write out your units in this way. In that way, you can see the units that can cancel out, and it will be easy for you to know the final unit for your answer. So mass of oxygen will do the same thing. There are 11 oxygen atoms, so it will be 11 mole multiplied by 16 gram divided by mole. So mole cancels out, and the answer will be 176 gram. So again, to get the mass of 1 mole of sucrose, we add the individual masses. So if we add these three masses, we will get that mass of 1 mole of sucrose is equal to 342.3 gram. Right, the next thing is to calculate percentage by mass of each element in sucrose. So mass percent carbon is equal to mass of carbon in 1 mole of sucrose divided by mass of 1 mole of sucrose times 100. We calculated from the previous slide that mass of carbon in 1 mole of sucrose is 144.12 gram. And we calculated from the previous slide that mass of 1 mole of sucrose is 342.3 gram. So we multiply that by 100. You can see that this gram cancels this gram. So then the mass percent carbon is equal to 42.10%. We do the same thing for mass percent hydrogen. So the value that we calculated for mass of hydrogen in 1 mole of sucrose is 22.18 gram. We divide that by mass of 1 mole of sucrose, which is 342.3 gram, multiplied by 100. So this gram cancels this gram, and our final answer is 6.48% hydrogen. We do the same thing for mass percent oxygen. The mass of oxygen in 1 mole of sucrose that we calculated from the previous slide is 176 gram. We divide that by mass of 1 mole of sucrose, which we calculated from the previous slide to be 342.3 gram. Again, this gram cancels this gram, and when we multiply this by 100, we will get that mass percent oxygen is equal to 51.42%. Again, all three percentages, this, and that, will add up to 100. So once the percentages add up to 100, you will automatically know that your answer is correct. So this is how to check that your answer is correct once all of them add up to 100. Right, so this is where I'm gonna end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.